Hey everyone, in this video I'm going to show you how to do an airfoil analysis on xflr5. So without any ado, let's jump into it. First thing I'm going to do is go to a website called airfoiltools.com. So this is our website, click on it. Now the analysis that I'm going to perform is on an airfoil called S1223. This is a Selig airfoil and I'm going to click the first one. Now this is the image of our airfoil and you will get a numerous details about this airfoil right over here. Now I am going to go to this link called source.file where you will get the entire coordinates of the airfoil. So I'm going to save this. I'm going to save it on my downloads file and note that this is going to be saved as text file format. Now that I have saved it, inside downloads tab I will get this file and I need to convert into a DAT file format. So in order to do that, I'm going to change its file extension to DAT. So you can see that now we can change it. And now the text file has been converted to DAT. If you are unable to change the file format by renaming, just go on views and just click on show. And you will find a tick box on file name extension. After clicking this, you will be able to rename your file extension using this simple method. Now that you have saved your file in that file, I'm going to open our website xfoil xflr5. So this is our application. I'm going to open our airfoil from downloads. So if you see our airfoil design, this has been imported. You can confirm it by going here. Now I'm going to perform an analysis. So I'm going to do xfoil diet analysis over here. I'm going to do point view. So this is our airfoil. First and foremost thing is that I'm going to refine the airfoil globally. What this will do is that it will increase the mesh size of our airfoil. So now that's done. Now I'm able to perform our analysis. I'll go to analysis. I will define an analysis. So I'm going for a simple type 1 analysis where I can change the Reynolds number value. I'm not going to change the Mach number or any other parameters over here. I'm just going to change this Reynolds number. This is going to be 5 lakhs for this analysis right now. Then I'm going to click OK. After confirming, you can see your analysis has been created. Now you have to do your analysis over here. It's on direct file analysis. I will click on alpha. Go and check your sequence text checkbox, and from an angle of attack of 0 degree to an angle of attack 20 degree, that's going to be my points of value with a delta of 0.5, and I'm going to just click on analyze. So our analysis has been done, that you can see here, and I'm going to click close here. After that, you can go to your polar view and you can see the graphs here. At first, you will get all graphs in this file format setting, and I am only interested in 4 of the graphs above here. So I'm going to click 4 graphs, and these are the graphs that I'm interested in. That is coefficient of lift versus angle of attack, coefficient of moment versus angle of attack, coefficient of lift versus coefficient of drag versus angle of attack. So if you watch carefully, I'm going to click on this graph, CL versus alpha. That will be our first graph. You can see that you will get a maximum of around 2.3, I guess 2.3 something value of angle attack. That's your maximum CL value. At around I will get around, I think, 14 degree or 15 degree. So that will be my, so this point will be our stall angle. After that, our lift constantly decreases. So in order to find the exact point, you can just simply zoom in and just find out at what point our airfoil will stall. So if you watch carefully, at 14 degree, this is the point with around 2.3, 2.34 in between that. So if I again go and zoom in, 2.338 and above. So this will be the value. If you want the exact value, just go and right click here and go to edit that points, and you will find all the angle of attack value with all the corresponding coefficient lift. And at 14 degree, I got the maximum angle of attack. So this is a 14 degree. And you can clearly see it's that 2.339 is our maximum coefficient of lift value. So this is how you get the maximum or the stall angle and the maximum coefficient of lift of our airfoil right over here. So I'm going to click save over here. And in order to save my analysis, what I'm going to do is that I will go on file and I will save this. And I'm going to save it in our downloads file with the name S1223 analysis. Or I'll just simply click S1223. That's it. And you can see that our analysis has been created in the file format of .xfl, and that's it. So I hope you enjoyed the video, and thanks for watching.